Good afternoon, and thank you guys for joining me here, and for anyone who's listening in for this discussion on 3D Gaussian splats. I'm here today with Tomas Barnas, Michal Gula, and Jeffrey Martin.
Hi. Hi, everybody.
Hi.
As our topic is focused on Gaussian splats, I was wondering if each of you guys would be able to give us a little bit of background on you and sort of why you deserve to be here in this conversation today. So we can start age before beauty. So Jeff, you want to start?
Sure.
So beauty starts.
I'm a co-founder, CEO of Mosaic. I've been involved in many different aspects of photography and imaging and 360-degree imaging for about 20 years, including substantial experience in panoramic 360 gigapixel photography. Generally, my experience in photogrammetry related 3D scanning is a bit less than that, but overall, I've been looking for interesting and viable solutions for 3D imaging for a long time, and we've been diving quite deeply into 3D Gaussian splatting technology here at Mosaic. So, I'd love to share my thoughts about it today.
I don't know who's oldest between you two, so Tomas or Michal.
Tomas, you go. I'm younger, but I can go. Thanks, Lynn, for the invitation. I'm co-founder of Overhead 4D and also of 3Dice conference together with Michael. And my core business or my core focus is photogrammetry and digitization of large and unique places around the world, which we are doing, I would say, like over 10 years. So I believe that's the point why I deserve to be here. And as we try to not only digitize what exists, but we also try to change it to past look or future look. We always play with the newest technologies, with combinations of the 3D scan data and integration of those data into interactive applications, where we come across nerves, Gaussian splats, and everything what is popping up on the market.
Yeah. My name is Michal. You can call me Michael. I've been in the reality capturing business for the last 9 years. Still my core business is laser scanning and photogrammetry. We do as-built documentations for existing buildings. So we help architects and designers to put everything together, because like 99.9% of buildings have documentation that simply doesn't fit to real existing building. And for the last 3 years, I've been heavily involved in LinkedIn content creation, where I went from basically 0 followers to 97,000. What I am focusing on is 3D industry, with a special aim to reality capturing and further usage and applications. So hopefully this is the reason why I deserve to be here.
Fair, I think so. Thank you, guys. So you kind of mentioned a few of these other different ways to visualize reality when you were kind of giving your little CVs. Can we just go back and maybe talk about a little bit about each of those before we get into Gaussian splats? So like what have been like the standard ways of visualizing our worlds before we get to Gaussian splats? So I think like actually Jeffrey, just again, because you've been in, or you're a little bit older and stuff, you started out with like 360 imagery. Can you talk a little bit about that?
360-degree photography in general has been around for well over a century. Ever since someone invented cameras, someone was trying to figure out how to, spin the camera in a circle and move the film through it at the same time to capture everything. So the idea of capturing a whole place, or capturing what a whole place looks like, has been around as long as photography itself. Now, 360-degree photography, as we know it today, in its interactive format, has been popularized by Google Street View since around 2007. So it's something that everyone is really familiar with, but it remains a fundamentally 2D experience. So it's just a photograph, but you can, change its position, but it's still just a photograph. It's not 3D. It's never been 3D. And anything that takes photography and tries to make it 3D. So you have, for example, like stereoscopic photography. So you have two cameras that are positioned slightly apart, and you can use some 3D glasses that gives each eye a slightly different view. And if you look at this and don't move your head, you do get some sense of depth, but it's still a photograph and it's not a 3D environment. What's been fundamentally exciting to me is 3D Gaussian Splatting is the first 3D technology that really feels like a 3D image. And it's different from the other stuff, which is like a, textured mesh point cloud, which is, it doesn't feel like an image. It's more like, it's a literal 3-dimensional object, which you are then visualizing, but it doesn't feel like a 3D image. And so this is the first time where I feel like there's a way to have like a true 3-dimensional picture that you can move around inside and within.
Mm-hmm.
I would just catch on that what actually Jeff mentioned, and that the point when we also started with photogrammetry, the problem was, and I think for everybody it was a problem, that it was not really the representation of the reality. You always had these issues like vegetation, this and that, glass, water, all these kind of problems. And that was actually something what was driving us to combine the technologies. So not just stay with that what scanner can give you or photogrammetry can give you, but also like how you can implement other softwares, and here I would say gaming engines, to bring back the life into those data. So the things which are damaged, how you can replace them and make them look actually better, which with Gaussian splatting now we probably will need less and less. I mean, like, we need those softwares, but those replacing won't be that much needed, because it was extreme effort always. Like, we always wanted to have a perfect data or perfect results visually, because most of our stuff in digitization of cultural heritage was not about like a super millimeter accuracy as you do on the constructions, but it's more about preserving something, what is there, maybe what is going to be destroyed because of the eruptions or any kind of let's say natural disasters or anything else. So our focus was like how to recreate this to make it look as good as possible and as realistic as possible. So we were doing a lot of combinations. Yeah.
My very first touch with the 3D per se was, as I mentioned, like 9 years ago when I bought the first Metaphor camera, and not actually seeing the panoramatic images, because you could get those from whatever technology, but actually the ability to see the dollhouse. That was for me the aha moment where I just fell in love with the 3D. Since then, like 2D is against my religion. I always believe that with every delivery that we do, we try to get our clients to experience the 3D space. Okay, so when we're delivering as-built documentation, it needs to be in 3D. So we use Revit for that. When we deliver point clouds, it's by its nature 3D. So we also support it with virtual tours where the client can actually experience this. So this is like to be able to explain why 3D is so important for me. But until now, or maybe still, it has always been a problem to deliver 3D experience in an efficient way, because 3D meshes can be huge. 3D point clouds or point clouds, these can be like exhaustingly big and huge. So it's always very difficult. And even though there are multiple cloud solutions that can solve this, it's still very slow. So when we, for example, found out about NIRA, for example, solution, which can like deliver these big assets flawlessly. That was a kind of a big moment also for us, because we can provide our clients with beautiful data sets without any limitations.
Well, thank you guys all for sharing that. And now I think we're going to start with kind of like the hardcore questions. So the topics, I sort of like 3 categories: technology, business, and then standards. So the first thing I wanted to get into on the techie side, since you guys are all very techie, is the ways that large-scale Gaussian splat projects diverge from photogrammetry or laser scanning in terms of capture, compute, and data management requirements.
Yeah.
Yeah, go ahead, Tomas.
I just wanted to say that for me, I wouldn't really say that it's devoting or differentiating so much from the overall idea of how to create that project. The only thing, like for me, like the main thing you have to consider is that the Gaussian splats are mainly looking good from the perspectives where the camera is positioned, which is also the case of photogrammetry and also laser scanning. So always like what you don't capture, you don't have. But it's in a slightly different way, because still, like if you fulfill the data with photogrammetry, then they are more consistent. So Gaussian splats, like if you also think about large scale Gaussian splats, then you are mainly, from my point of view, capturing them with a drone, flying around like oblique missions, most probably. So you, of course, don't expect people be standing on the ground. Yeah, and that's something what is very similar for me. Therefore, I'm saying, like, whether it's photogrammetry and Gaussian splatting, you always have to think what is the final outcome of the project, because you have to be focused and you have to build your pipeline based on that what you want to achieve. And in that case, you can be very effective, and you can also like create the data with not like a huge amount of images or data behind it, which are capturing actually that what you want. So from that point of view, I would just like say, for me, it's not that much different, and also from the way of how you publish it or present it, because also large-scale Gaussian splats are using kind of I don't want to say LODs, but they are using more like the tiling, and also reducing the quality further and closer. They are like more detailed, further they are less detailed. So I see there are a lot of things which are overlapping, and maybe in the details of the technology it's different, but overall I see it more like a similar direction.
Okay, thanks.
Yeah, I would agree. I would say the capture it's very similar. And in fact, the first stage of processing the data is pretty much exactly the same. You have to take a bunch of pictures of everything from every direction, and then you have to establish where those cameras were in space relative to each other as precisely as possible. And that is the same for whether you're going to create a point cloud or mesh or Gaussian splat. Like that stage is the exact same thing. But then creating the representation is the second stage, and that's where it's a completely different process. And I would say that a couple of things: the ability to view the scene in a kind of the maximum quality, or in a quality that is as close as possible to the original, is it seems a little bit easier with Gaussian splats. Like on a website, on a web page with a mobile phone, this general process is just easier to handle. So it's a much more easily consumed medium. And it seems a little bit more forgiving of like mistakes or gaps in the data, just like the way that the data deteriorates in the final view. It's somehow more pleasing looking in a Gaussian splat than in a mesh model, where you'll have just like, you'll have a hole. You'll have a hole, or you'll have some like massive triangles, and kind of the failure mode of Gaussian splats seems a little bit more forgiving.
I can just agree with guys, because at the first moment, but because before 3D Gaussian splatting, there was nerves, right? It's still there, but this was like the first paper from NVIDIA showing this girl that and claiming that we took only 4 images and recreated the 3D model of the lady. So this nerve is groundbreaking, and then you can use only few images. No, you cannot. I tested it right away, and it simply didn't work, because the point of these technologies, either nerves or Gaussian splattings, is not that you can put shit in and you get gray things out. If you put shit in, you get shit out, right? So the main idea is that exactly what Jeffrey mentioned, like it's much more forgiving. Like, you still need to use similar workflows to photogrammetry to capture all the angles and everything. But once you are missing some data, it still looks good enough at the end. Another thing is that once you want to capture not only small objects or limited objects, but also the surrounding environment and this stuff, then you're screwed with the photogrammetry. With 3D Gaussian splatting, you can get the whole perspective of all the surrounding and everything else.
Yeah, that's the key thing with Gaussian splats that is fundamentally better. Like, it gives you the background, and it gives you whatever was in the original photo. You have that. So when you look at the scene, it always looks much better than the equivalent 3D model. There's things that you can't do with it. It's not better in every way, depending on what you need to do. Like, if you're going to do some 3D manipulations, then that doesn't really work. But in terms of experiencing and looking at it, it always looks much better, because you have the background, you have whatever is in the infinite distance, and all of that.
Well, the so far solution was to use skybox like on the background, to use just panoramic image and just to pretend to have a background, but it always looked very weird and like visually not consistent.
Yeah,
right?
yeah.
But with the 3D Gaussian splatting, this is like changing heavily.
I like Jeffrey just like said before that this is actually, because you were looking at 360s as a representation of reality, and this is now, it's a 3D image. So I really like that, because it's not about like 3D data, it's about being in 3D image or 3D image space. Like, you're really like looking into an image from any perspective. You can pick perspective, so it's kind of like a calculation of like different images inside of one scene. So that's a nice comparison, I would say.
Mm-hmm. I was going to go one way, but just Jeff, because you mentioned it about being able to manipulate the like a 3D model. So right now, like, how effectively can we integrate semantic understandings into like Gaussian splats and allowing the systems to recognize, interact with individual objects and be able to like manipulate the scenes within a Gaussian splat?
I think this part is just not mature, and this whole technology is not mature. It's only a couple of years old, and I think people are trying to do it, and it's starting. But there are some fundamental things about both a point cloud and a bunch of 3D Gaussians that are different. Like, it's not a watertight model. So if you're going to do actual physics to it, it doesn't work. Like, you can't do physics to a bunch of points in space like you can with triangles that have topology. Like, there's no topology here. Topology is is a field of mathematics that involves surfaces, and whether something is closed or not, whether it has holes or not, and it sort of doesn't apply exactly to this type of data. So I think it is fundamentally a little bit difficult. But that said, I think someone's going to figure out how to make it work to some extent. And we ourselves have done a few things. Like, we did a Gaussian splat with, we added stuff to it. We added some lights and some animations, and so some things are possible to an extent, but it's going to be hard.
For me, since you mentioned physics, it's even worse, because it's not only points, the Gaussian splatting. It's this weird bubble space,
Yeah.
and you can never tell where the bubble starts or where it ends when you're looking through the ray of the light, because it comes with colors, it comes with transparency, with different angles, with different reflections. So it's very difficult to identify an exact space in a exact position in a 3D space, like where that point belongs to. You can see it perfectly. You can your brain can interpret it and say, okay, I understand that this is a cube, for example, and I understand where are corners. But in 3D Gaussian splatting, if you turn it other way around, you can see it very differently from different angles. So I have seen several solutions where you can already do with 3D Gaussian splatting. You can erase things that you don't want to be there, but it all again comes with very limited ability to select exactly what you need to remove because of these splats, right? In terms of physics, it's very easily fakeable, because at least in solutions that I have seen, they just use transparent mesh on the background, and you just somehow have this Gaussian splatting that is actually following the physics, right? So we don't need to, I don't think that it's a good thinking to try to replace photogrammetry in a full spectrum with 3D Gaussian splatting, because it's not here to replace photogrammetry, it's here to enhance it, and it's actually a very different way of representing the reality in digital world.
Yeah, and for applications, sorry, Tomas, go on.
No, I just wanted to agree with that. This is exactly like we have, I would say, like on every conference we had in past like few months, there were many of them. And there is always a discussion, like someone is coming and saying like, I don't know, like one group of people says like Gaussian splats are unusable. Another group of people say like it's a replacement of photogrammetry or whatever else. For me, like this is just the complementary technology, which is bringing another layer. I like to say it in that way. For me, it's a layer. It's a layer of like laser scanning, it's a layer of photogrammetry, and it's a layer of Gaussian splatting. I'm not killing any other technology by this. Maybe if we would like, then Gaussian splatting is closer to maybe destroy photogrammetry world than laser scanning world, but still not, because we are getting like 3D meshes, watertight meshes, textures. All of these things are necessary and needed for certain fields. And I would just say here, like in our field means where we are not that technical, and it's more about like digitizing and preserving what exists and then reconstructing it. This is the ideal technology to put over all of those scans we had, or just use all the data and reprocess it again to get better and more realistic visuals. So I really don't see it as, if I wouldn't even open a discussion whether it's destroying something or replacing something. It's just another step in the pipeline which can be created within very similar time of capturing. So you are just like capturing your old methods, and you can decide later whether you do photogrammetry or laser or Gaussian.
Yeah, that's a good point, and I definitely agree that it's another layer and another way to process data, which will have more or less importance depending on what you're doing with the data. For purposes of just looking at it and visualizing it, I would say it is really superior most of the time. I would say in terms of the technology, what really interesting is that it's bringing this AI stuff and neural networks into making a bunch of images from a bunch of places unified, and this is a new thing. Like until then, it was just kind of some very basic geometry. Like photogrammetry has been around also like photography for well over a century, and it's the same thing. We're just doing it billions of times instead of like 4 times to find the height of a mountain, but otherwise it's the same deal. But this is something different where, you know, you've got this neural network and it's got all these pictures and it's creating a, you know, you got a picture here and a picture here, and then it's like, okay, well, let's create a view in the middle and let's compare it to what the actual pictures look like, and it goes back and forth, and it which is called back propagation. It's comparing it again and again and seeing like where it made a mistake. And so this technology is really interesting, and it's where, you know, maybe Gaussian splats aren't the very last thing, but it's this, you know, it's the same deal as NeRFs, and it's this you know, it's a fundamentally new way of applying this exciting new field of computer science to getting these environments to look really cool, basically.
For me, very important word here, or keyword, is context. Because once we are speaking, for example, about laser scanning, Gaussian splatting is not going to replace laser scanning with millimeter accuracy, like never. Same if you need to recreate the high detail digital replica of some object, photogrammetry is still the way how to do this, right? But 3D Gaussian splatting allows for context. Like you can place that object in a context of surrounding. You can create the digital copy of some building and to place it in the context of surrounding. We already mentioned this before, but this was again 2 years ago for me, when I didn't have to place my scan to Google Earth or similar solution, and I could just place it in a 3D image, as Tomas mentioned. That was a huge for me, like for me personally, to be able to represent my scanning solution, my scanning outputs with actual surrounding and context all around.
So you guys kind of jumped over to my next question, which was about accuracy. And I know those from the surveying industries are very, very particular about accuracy, even though of course it's a range and like what customer, what project, that always makes a difference. But you know, I think the common belief now is that Gaussian splats are not accurate or not accurate enough. And so if you guys could just talk about like why right now that is more or less true. And like you said, it's not about replacing scanning, but like not like, yeah, if you could talk about like why that is true now, but also like, do you see that gap closing, you know, with newer technologies or just like better improvements in Gaussian splat pipelines?
Can I?
Sure.
No, I would just like to repeat more or less that what I said. So if surveyors don't like the technology right now, like no one is taking their accuracy away. And again, I would just repeat, like it's another layer, it's an overlay on top of their data, so they can make super accurate point clouds measured with total station, anything. And if they get a point cloud, they can overlay it with the Gaussian and get like nice visuals on top of their accurate data. They can still merge it afterwards. And then like, why wouldn't you do that? Like you have an option to create something on top from very similar sources. Also, of course, not from laser scanner camera, but I just like don't really get that point if you want to fight against like it's not like if you don't need it because your clients don't require it, it's fine. But on the end, you can just put it on top and keep the accuracy on the back end. You don't have to get it from laser scanning, from Gaussian itself.
I guess there can be a misunderstanding. If you can create this beautiful looking visualization, then people might assume that it can also be dimensionally accurate, and capturing this beautiful visualization might be a lot easier. You might even be able to just do it with your phone or, you know, with a few cameras. But using a total station and a you know, terrestrial laser scanner, this is like, you know, a little bit more serious and expensive. And, of course, that'll always be possible to do, but people might not always understand that, you know, these two ways of scanning a place are, you know, also very different from one another and won't lead to the same results.
I will try to be offensive to several people at once right now, because surveyor asking about the accuracy of the Gaussian splatting is something similar as a vegan comes to a Michelin restaurant and is asking whether there is a meat or not. Like, that's not the point. You are totally missing the point. Like, it's like you have a bus and a Formula One car, and you're asking about the speed of the bus compared to Formula One. Like, you're totally missing the usage and the whole point. And I like the interpretation of Tomas where he said that it's different layer, it's different use case. Like, we haven't had this before, now we have it, but it's something different. It's not here to replace any of existing things.
But I can, like, I would just bring here one point where as Michael has like 2Ds against his religion, I could say, like, when I was starting with photogrammetry, it was like 360s against my religion. So there I was really like not understanding why Jeff is always pushing so much the 360, because I was following you, like we were in contact for years, and you were always like, it will be good, I will be developing, and there you see, like, he had the trust in it, and now came a technology which is, I would say, okay, maybe here is the difference between photogrammetry and Gaussian splatting for me, where Gaussian splatting can perfectly be created by 360. And here I would say, like, Jeffrey was focused on the images and 360 images, and this came now into a reality, and we're getting these 3D images. And I think, Jeff, you got just ahead of many people just because you spend the time on, like, being focused on it, you know. And this is exactly like surveyors are focused on their data, on the precision, but not really. And now I think it's like my case. I was not looking into 360 because currently in that point it was not bringing me benefits. But in certain way, when you achieve that level and it brings you the benefits, then you can see the advantage of it. But you have to find that use case. That means if someone or some industry or field stays with their standard focus, it doesn't mean it's bad. They have their focus and they maybe don't need the Gaussian splatting. But maybe if they open up the door, they will get maybe another clientele, maybe they get another projects where it can be beneficial. So it's just for me, like, exactly looking at 360s where I wouldn't touch them. And now I'm really looking into that, to have a 360 camera and doing Gaussian splats with that because it's faster. And then you would ask me 2 years back and I would still say, like, no, I would never do it.
I think just to respond a little bit to that, it was partly out of stubbornness and using the tools that I'm already familiar with, but I think mainly it's like pure, I don't want to say laziness, but, you know, desire for efficiency. And if you're gonna walk around taking pictures, like, for God's sake, why would you use like just one camera if you can use like 6 cameras at the same time, especially if they are, you know, have a position that is locked relative to each other and they're, you know, synchronized properly. This should be much more efficient and much more stable overall. But the problem that we faced initially was that there are certain software tools that don't accommodate this, because it is not the most common way to do photogrammetry is you have one camera and you walk around with the camera, like, you know. So not every software supports this.
To just add one thing, it was for me, like, I was more always thinking, like, why people want to use stitched 360 cameras or images which are divided later. If you can have, for example, you can have 5 cameras, but you can have them mounted around. But that was kind of like, I always was received like that. That was a compliment that you had, like, your vision of building something out of maybe like 99% people didn't really pay attention to it because it was kind of not accepted by the softwares. And you went through it and it was created. So therefore the comparison.
Oh, thanks. I think that being said, I think for just general 3D scanning using cameras, we're still in this stage of the technology where like it's all just sort of a hack, and you're all like we are all using kind of a suboptimal like camera capture device where I don't know if you could have like 100 cameras on a really long stick, that would be, you know, dramatically more efficient to the extent where you could, you know, do stuff that is literally not possible today. But, you know, building that hardware and those tools is, you know, maybe not economically possible. Maybe there isn't a market for that. So it's hard because processing all these images, it becomes quite challenging. You know, the processing behind it, which I guess we're going to get to this subject as well, is, you know, is very substantial, difficult.
Before we get to the processing, just to like the hardware for capture, and Jeffrey, since we're talking about like cameras and 360 imagery and all that, how much do optical components influence the splat fidelity compared to like the advances in the algorithm?
I think this is a part of where the splats are probably more forgiving than the photogrammetry, where I would say like the optic or the quality of the sensors are pretty like direct in quality comparison. If you have like bad sensor for photogrammetry, you are getting immediately bad results. But I just saw, I think 2 weeks back, when I was with on the conference in Abu Dhabi, and we had discussions there with Ted, and he was showing me different like approaches or results from the Gaussian Splats and comparing it to 360 spherical image, which was used for processing it. All of those images were way worse than the final result. So here I would say like the optic and the sensors can be worse, and the Gaussian splat still can be good, because it's like with multiplying, it's kind of like multiplying the quality, which is not the case in photogrammetry. Like if you have multiple bad results, you will not get better photogrammetry, you will get worse. And this was for me surprising, like seeing that the image itself from a lighting perspective, color perspective, quality and detail, everything was worse on the source image than on the final outcome.
Mm-hmm. Maybe guys that are deep into technology mathematics behind the 3D Gaussian Splatting, they will maybe bash me for this, but I'm not in mathematics and I'm not a coder, so this is just my perception of the problematic. Like when we are talking about photogrammetry, the whole point is for the software to place exact tie points in the space, with the target to at the end recreate the object that you're capturing. With the 3D Gaussian splatting, again, it's my feeling of how I perceive this, is that the software is actually trying to place the camera, not the tie point in the 3D space. And once you place cameras as accurately as possible, then it's much easier to replicate what you are looking at than the other way around. Hope it makes sense.
That makes sense. Tomas, it would be really interesting to see this data set that you speak about. It sounds really interesting.
I can ask him, because that was actually, I think they have it also on Nira online. That was the huge hangar. He had like very Ted Strasimiri, like you know him for sure. So and he had a post that was like the hangar with planes, with engines, with everything, like reflections, glossy, wide, whatever, anything but good space for photogrammetry or laser scanning. And there was this comparison. So I'm like, I can just look for that later, or maybe you can just check his profile, and it's one of the last posts he had also.
So I was going to move on to some like business topics related to this as well. So as you guys are all business owners, and you've probably, I think in these fields, you've had to buy a lot of expensive hardware and software over the years. There are now some devices on the market that are specifically built for Gaussian splat capture and creation. But if you were maybe like giving advice to someone, how can business owners ensure that today's data sets remain valuable across future rendering methods as well, and not just maybe specific for one rendering method?
Simply, you should just save the raw data, and you can always reprocess it with the newest technology.
I was going to say the same thing. Just shoot raw.
Yes, shoot raw, exactly.
Yeah, the same here. Like my first thing was to go through all the datasets that we had shot before because of the photogrammetry, and then to reprocess them with the Gaussian splatting, and just play with it and see how you can use it or not use it. Show it to clients to see their wow, right? So yeah, it's the easiest way how to start with 3D Gaussian splatting, just to use the datasets that you already have.
Mm-hmm. Mm-hmm.
Yeah, and yeah, just saving the original data. It might pile up, but hard disks are not that expensive. You don't need like 5 copies of everything. Just put it somewhere, and it will certainly give you something nicer in 5 or 10 years time if you reprocess the original data. I would say that is almost certainly going to be the case.
That's actually maybe also a good advice for everybody, because everybody's running out of disk space, I would say, in this world we are living, because you have a huge amount of raw data, then you process the data, then you have a final result, then you have the projects. And most common thing you would do in the first moment is that you store the final result, because that's easiest for you to catch and maybe reuse or look at it. But actually, it's the other way around, because if you store the final result, you will never change anything or adjust on it. So the only thing what really makes sense are the raw source data which you had as a capture, because you can always be processing new things out of them.
So as adoption seems to be increasing, I think across our industries and other adjacent industries, what financial, technical, or talent-related constraints do you think are most limiting to like the adoption of Gaussian splats?
I have gotten this question several times, like
Yeah?
like not this exact the one that I'm going to tell you, but the question was like, what's your commercial way how to use 3D Gaussian splatting, in terms of, have you already been able to sell 3D Gaussian splatting? I don't think we are there yet, and I'm not sure whether this is really the case, to be offering a 3D Gaussian splatting as a final output. We mentioned this several times here. Tomas said it, like it's another layer. So you can offer this as an add-on or upsell, or you can just add it as a bonus to all the deliverables you are doing right now. But I'm not sure whether the simple 3D Gaussian splatting should be sold as the final product.
I'll disagree with that.
Go ahead.
So I think if we would consider, there are lots of different people in industries that are selling some kind of 3D experience or 3D visualization, and they're selling this to end customers who are buying some 3D visualization, and they might not even know about or care, like, what is that? Like, is it a point cloud? Is it a mesh? Like, they don't know, they don't care. They just want to like look at their restaurant in 3D and like walk through it as if it's a video game. And they don't care if it's point cloud or whatever. They just want it to look good. And if you make a textured mesh and you have all the correct material settings, or if you have a Gaussian splat, it doesn't matter. And maybe they won't even be able to tell the difference in the end if you do both of them in a good way. So I think, for a certain type of creator and a certain type of customer, this is just, it's selling the same thing, sort of. It's just,
but this decision is made on your side. But I'm saying that you should never expect like the end client to come and say, please sell me 3D Gaussian splatting, because
Right.
A, they doesn't know it, they don't understand it, and B, just the 3D Gaussian splatting doesn't make sense for them, because, for example, from I don't know, like surveys, they also want a very precise point cloud, for example, right? For I don't know, like if we are doing as-built documentations, it's not enough to have only 3D Gaussian splatting. They also want the BIM model or whatever, right? So it can be only a part of the solution, but the decision would be made on your side, I think, at least.
Yeah. So on that point, we agree. I think in the end, we are creating data sets, 3D data, and someone's consuming it. And whether or not that happens to be a Gaussian Splat or something else shouldn't always matter. But I think now with this tool, it can be more viable for someone to create something that looks better a little bit more easily, and the customer will be happier with less work happening, depending on what you're doing. Like, again, if you're like, I was, 20 years ago, I was trying to shoot 360 photos of businesses and sell it to them and have it online. And they didn't know what the hell it was. Like, there was no Google Street View even. They didn't know about 360 photography. So I was trying to sell something that they didn't know it existed. So it's like Gaussian Splat. It's like, hey, let me sell you a Gaussian Splat. What the hell is the Gaussian Splat? Is what everyone's going to say. Like, everyone's going to say that. So no, you can't sell that. Let me sell you this amazing 3D environment. Oh, cool. Yeah, you can sell that.
Yeah, I would just exactly so agree with those two things. But where I would say, like, it's, for me, it's incorrect way to think that you are selling the name of the technology. Because for me, over my 10 years, I'm working in this industry. I don't remember a simple case when someone would tell me, I want the photogrammetry model. Like, I don't, they even, like, when I said, like, they cannot repeat it until now, like, no one. And literally, like, now, just like yesterday, it happened to me that like a client called me and he said, like, we saw what you have done for that building. We also don't want to measure our building by hands. That was the order. The order was not, I want the laser scanning data, or I want like mobile scanning or something. It was just like, I don't want to measure it by hand. So it's also about the education of the clients. And I don't know, I just like learned for myself, but that's more because I'm in the cultural heritage segment, that I'm not expecting from clients to name the technology they want from me. Like, it's great if they can name what they want to have as a result. And it's our target to deliver them the right technology. And if we decide it's Gaussian splatting, we're selling Gaussian splatting because it's that what they need to receive.
They might just call it a 3D scan. Okay, you want a 3D scan. Do you want it to do measurements, or do you want it to look cool?
Yes.
These are two completely different things that we will do by 3D scanning, right?
Yeah. Exactly.
So then, again, sort of like your recommendation to other business owners, like, how much time and energy would you put into investing into, like, either the hardware, the know-how, to like bring this technology into your company? Like, what would your advice be?
I mean, you can currently, if there is anybody who was doing laser scanning or photogrammetry, they almost don't have to invest and they can try it. Because you get the results from that, what you have. And then if you want specific devices and you are in the field of laser scanning, then the devices for Gaussian splatting are cheaper than those which they have already purchased for the technologies. So I would say, like, a price range for getting a good Gaussian splat results are lower than for having a professional laser scanning devices.
I was spamming this also with the photogrammetry. Like, the easiest way is to pull your phone out of your pocket and just start shooting. And it goes same with the 3D Gaussian splatting, and it's even more easier because, as we mentioned earlier, it's much more forgiving. So you don't have to actually be very precise as with the photogrammetry. You can, I have tried it several times, you can just walk through the street with your phone in front of you, and it will recreate the 3D Gaussian splatting. With the photogrammetry, you would be really F-word.
What about on the post-processing side? I know there's some sort of like, piecemeal pipelines that people are working on themselves. Some like the larger players in the industry are also building their own pipelines. So right now, if you're like a small business owner and you're trying to figure out how to do this, like what is the investment on your side to actually be able to do this? And like, is that also like, taxing on your resources?
It's again very similar to what you had. Like, it depends where you want to get with it. Well, when you are starting, everything is affordable, and then when you want to have like a huge scale Gaussian splat, and probably you really need like powerful computing power, or if you use cloud, then you pay a lot for cloud processing. But that all depends on the scale. But for beginning or starting with it, it's just, for me, pretty straightforward and not expensive.
It does seem a little bit more difficult in terms of the processing of hardware than for photogrammetry, where you might actually need some, like for a big data set, you might need some disgustingly big amount of VRAM that is only available if you either buy a video card that costs like $50,000 or start running something in the cloud, which is totally doable, but takes some, a little bit more specialized experience than running something on a desktop. So it does seem a little bit harder to manage like very large data sets, where with photogrammetry, it's easier to just kind of chop it up into smaller pieces.
I hope usually newcomers through 3D Gaussian Splattings would be people that are already either in photogrammetry or laser scanning. So somebody who by default has like good machine, better desktop than compared to some administrative work. So just to start and just to try Gaussian splatting with several hundreds of pictures, for example, it's totally fine to start with basic better computer.
Mm-hmm. So you mentioned like, oh, go ahead, Jeff.
Oh, I was just gonna say the interesting contrast though is once you have applied this crazy amount of GPU power, the resulting data set is kind of often much easier to consume and to show.
Michal, you mentioned like taking a couple hundred photos, and I don't know the latest count, but I know, people are kind of finding limit to some of the current pipelines at maybe a couple thousand, a couple tens of thousands, but like, I know we have a large data set of Prague that's, many hundreds of thousands of photos, over 1 million actually. So like what sort of breakthroughs in terms of the technology are we needed before like splats are like enterprise ready?
Again, I'm not into every paper, because since the mathematics is not where my focus is, and the whole code and papers and everything else, I can see only experience from other people and some posts and some news. So I have seen several datasets which were coming from tens of thousands of pictures. Mm-hmm. The answer was just do it in batches. You cannot process this in this amount. The processing workflow is a bit different compared to photogrammetry. I know that Tomas has in a photogrammetry way processed more than 100,000 of images. I have seen data set of the Titanic, for example, created from 700,000 of pictures. But you wouldn't be able to do this right now with the 3D Gaussian splatting. You would have to just separate it probably to smaller batches. Am I right, Jeffrey?
I also agree.
Good. So just in terms of like formats and standards, right now, if core splatting methods move from open source to proprietary ecosystems, what risks emerge, and how should businesses hedge those risks?
on a software side, I mean, like if
Hmm.
I don't know, it's like this is maybe a question for developers, but it's something like where you see the softwares like I would say Blender, which is open source for ages. Then you have the softwares which are locked. You have to pay licenses, and both worlds are alive and doing their stuff. So I don't know whether there is something to be aware of, or like I have no idea here.
Hmm.
It would need to be something very different to compare to what's actually existing, because if somebody locked their code and the way how they process Gaussian splatting, and it would be very similar to what is actually out there with open source or with very affordable prices, like people wouldn't care. So it really needs to be something like, as we mentioned before, like processing of complete huge data sets, or I don't know, like taking a video of metrics and being able to reprocess it in 3D because of the 3D Gaussian splatting. I'm just kidding here, but something that would be really a breakthrough, so that it makes sense to lock it, right? But without that, I don't see the really meaningful reason for keeping it locked. We are still at the beginning of the technology. So if you want to grow your brand, giving out the solution of 3D Gaussian splatting, you need also to support the growing of the market, and you won't be able to do this with locking your solution.
Hmm.
In the end, it comes down to building a great product, and if there is a great product, people will use it, and being great is, partly depends on, the cost, partly depends on if it's usable, if it's a pleasure to use, and whether it's open source or not, ultimately doesn't really matter. It's a question if it's a great product that people use or not, if it becomes popular.
Yeah, therefore I made this comparison, because for me it's a thing where I would say over the years, I just bring it back with the Blender. It got maybe into a position that is maybe one of the most powerful 3D softwares on the market, and it's open source. But it was not like 10 years ago or like 5 years ago. I don't know exactly when it was created. You would ask people, and it was like just B-class studios were using it. So whoever was the A-class was always using like Autodesk or whatever what is paid, because you didn't want to have this free software. Now it's kind of balanced, but you still have studios which are using Autodesk and which are using softwares which are which you have to pay the licenses, even though it's delivering maybe the same thing. So I don't know whether it's about like being totally different to get paid. It's more about probably the marketing you build around, like if you get the trust of people and you're delivering everything so that they get maybe added value, that you have like a direct support, that you have like whatever around for what people want to pay, then you can get paid also if there are many open source solutions.
Mm-hmm.
I think on the processing side, it would be very similar to Photogrammetry, for example. Like, I don't think that company that would come as a new company with their locked solution and tell you like, it can process your data set 40% faster. Okay, it would mean something for very limited amount of people and companies, which are really with heavy data sets and day-to-day business and everything else. But for the majority of the market, it wouldn't mean a thing, right? It would be something new, something for a higher price. I don't know, right? With the 3D Gaussian splatting, I think it's very similar. Like the efficiency of processing side of the 3D Gaussian splatting is not something that is bothering most of the people. Most of the people are dealing with how we can sell it, how we can use it, how we can measure on it, how we can use physics, how we can implement it in Unreal Engine or Omniverse or wherever, right? They don't really care about whether it's going to process 10% or 30% faster or slower. It's not that important, right? So that's why I think that the processing part of being open source makes much more sense. Even, for example, Michael Rubov mentioned that every day there is like 5 new papers about 3D Gaussian splatting. So thinking that you could lock your development of your 3D Gaussian splatting solution and be able to beat the market with this fast development, you should be a crazy person.
Good point. And Tomas, I know you had already spoken about this earlier, and I remember one of your projects where you had combined photogrammetry and Gaussian splats. And so I guess, like, do you just see that as the pattern going forward, that more and more companies will offer this sort of combined solution and be able to, like, layer on all their different formats, and they're, talking again about like open data formats, so that they can access their data across multiple platforms?
For me, definitely. I mean, like there's like not even a question like why we wouldn't do it. We actually now, like, we are processing Gaussian splats from every project we are doing. And then we are deciding which part is based on, like, because we always have a combination of laser, photogrammetry, and now Gaussian splats. So that's a standard pipeline. And then we see which parts are selected from which technology combined into one package. And I don't see it's different for like the future. Of course, there are many things which can come, but so far this is our standard pipeline, and every project will be the combination of laser scanning, photogrammetry, and Gaussian splats for us.
And does that significantly increase
So
like resources, money, time, all that?
No, actually it's decreasing for me, because the point is the context, which Michael was mentioning, that for our clients, it's very important to get the entire context and not only the information about these accurate data. So we have the accurate data of the place they need, but they need the context, the stuff around. And this, I would never be able to create it for them with the resources they normally allocate for it. So we would speak about 360 panoramas, which was never like interactive enough. You are changing lighting, you are doing like various things, and here we are really like free with everything. So you can kind of, if I would say it in that way, you can deliver in the same day the same amount of money and time, way more than ever before, just because of this. And then it's up to you how you position it, whether you are upselling it on top, or you are using this as a benefit that the results are kind of like better in that way. Okay.
So you're actually either monetizing or at least adding value right now to your deliverables to your customers with Gaussian splats.
We count already on it, and like we have various packages when we are like offering the projects. And if it's pure digitization for technical reasons, then we normally don't do it. But we have many of the outcomes of our work are interactive applications, or something what is used also for marketing, so not only for technical use cases. And this is extreme upsell for them, because for the marketing, for like, you are getting the data, and let's say if you raise it like 10 or 20% on top, and you are creating the entire world around, it's like extreme added value in comparison of how much work and effort you have to add on top. So it's like, this is like, for us, it's very good selling point of using Gaussian splats, but not explaining to clients what it is. I can barely, like, many times explain how photogrammetry works. So yep.
Yeah, I can only agree on this point that your client does not care what changes you make to engine in the car. He just cares whether it's going more quiet or faster or more efficient on the gas, but it doesn't matter how it's called or what exactly you did to the engine, right?
Yeah.
Okay. Those were most of my questions that I can see. So does anyone else have any other things that they wanted to talk about before we close up?
It's a question for Michal and Tomas. When are you guys going to make another great conference?
May 3rd and 4th?
Or 4th and 5th, right?
Okay.
Michael, 5th and 6th. 4 is four is the date for us to build up everything. So please
Yes,
don't invite people to that date. We need to get ready.
All right. I think my dad's in town. I'll have to bring him along.
No. It's very important. The 4th is very important, Thomas, because it's the day of the VIP event,
And
where you will meet all the important person.
okay.
The very important
It's
person.
very important. People, yeah. No, definitely we are full in like in planning already. Like the venue is of course booked. So there are also some technical updates that they made a new LED screen and a lot of things are going on. So we are really looking forward to this year as well. And as it's not the first year for us now, we are more comfortable with all the planning because we know what is needed. And yeah.
Cool. I think lots of people are more than happy to have an excuse to come to Prague. So I think it's really a great idea to have a conference here.
Yeah,
Yeah.
definitely.
And we don't have to travel, so
Yes, it's especially because of you. We did it in Prague.
Thank you.
We knew that your schedule is so booked or overbooked that the only way how to get you to our conference would be to do it in Prague.
Good. Thanks for that.
What wouldn't we do for our platinum partner, right? Yeah.
Um,
All right.
Accept it?
what's that?
Did you accept the platinum partnership?
Yes.
Only in writing.
Okay.
Anyways, guys, thank you so much. I really appreciated it.
All
Take
right.
care.
Nice to see you guys. Thanks a lot.
Okay, thank you.
Bye.
See you.
Nice to see you. Bye.